DAT21703 study that examines how a laptop performance may be affected by its duration of use. One important performance indicator is the system startup time. Startup time refers to the duration it takes for a laptop to become fully operational after being powered on. This study analyzes the relationship between laptop age and startup time using statistical methods. The findings are expected to help us understand how the age of a laptop affects its startup performance. For problem scenario 1, our study focused on the startup time of laptop. As laptop gets older, their startup time may increase. This means users could experience delay when starting their laptops, which can affect efficiency. Therefore, this study investigates whether laptop age actually affects startup time. The data we collected includes the age of each laptop in years or months and the startup time in seconds. For the analysis, we will use simple linear regressions in Excel to examine the relationship between laptop age and startup time. A minimum of 30 laptops will be tested and each laptop will be measured 2 to 3 times to ensure the accuracy of the data.
To begin our study, we used the Villa table as a structured approach to organize our problem solving and learning process. In the first sections, we identified that laptops have different age and startup times, and that all the laptops generally take longer to start. From the idea session, we assume that laptop age could affect hardware efficiency, where software updates and background applications may also contribute to slower performance. In the learning sessions, we focus on understanding what linear regression is, how to calculate slope and intercept, and how to interpret values such as R-square and correlation. Finally, in the action plan section, we plan to collect data using Google Forms, analyze with Excel data analysis toolpack, perform manual calculation to verify results, and refer to lecture notes and reliable sources to interpretations. Overall, the Villa table helps us plan the study in a systematic way and ensure that each step aligns with our research objective.
For this part, we focus on the variable and data collection method used in our study. The independent variable is the laptop age, measured in years or months. The dependent variable is the startup time, measured in seconds. Both variables are quantitative. For data collection, we will collect a minimum of 30 laptops of different age. The startup time of each laptop will be measured using a timer or stopwatch. 2 to 3 timers per laptop to ensure accuracy. All data will be recorded in Excel with 2 columns, laptop age and startup time. We will calculate the average startup time for each laptop. Finally, the data will be analyzed using simple linear regression to determine the relationship between laptop age and startup time.
For this study, I used simple linear regression to analyze the relationship between laptop age and startup time. The analysis was done using Microsoft Excel Data Analysis Toolpack. This table shows the collected data from 30 laptops. It includes laptop age in years and their startup time in seconds. The data were collected using Google Forms and were used for the regression analysis. From the regression results, the multiple R value is 0.593, which indicates a moderate positive relationship. The R-square value is 0.3517, meaning that about 35% of the variation in startup time is explained by laptop age. The regression equation is y equals to 8.3461x. This scatter plot shows a positive linear trend between laptop age and startup time. Based on the regression equation, startup time increases by about 8.35 seconds for every 1 year increase in laptop age. This supports the regression results.
This section highlights the comparison between manual and software-based regression analysis. The purpose is to show that the statistical process beyond just relying on software. Manual calculations were performed using standard linear regression formulas, where I compute the slope and intercept based on the collect data. The result the resulting regression equation was y equal 8.3461x plus 10.51 with an R-square value of 0.3517. These results were then compared with those generated using Microsoft Excel data analysis toolpack. Both methods produced identical values, confirming consistency between manual and software outputs. This comparison demonstrates that while manual calculation help reinforce statistical understanding, Excel offers a faster and more efficient approach, especially when working with larger datasets. To conclude this study, we found a moderate positive relationship between laptop age and startup time. The regression equation y equal 8.3461x plus 10.51 show that for every additional years of laptop age and startup time increases by approximately 8.35 seconds. The coefficient of determinations R square equal 0.3517 indicates that 35.17% of the variation in startup time can be explained by laptop age alone. This means that while older laptops tend to start more slowly, other factors such as storage type, background applications, operating system conditions, and system update also play important roles. By using both manual and Excel-based calculations, we were able to verify the consistency of our result and strengthen our understanding of regression analysis.